Okay, today the lesson is about logarithms, right? So this first part is I'm just trying to motivate where do logarithms come from and why were they developed, okay? And that's where this question comes from. Just given these two numbers, which are really not that big of numbers, right? Would you rather add two three-digit numbers or multiply two three-digit numbers? You'd probably rather add. It's a little bit easier operation. I wouldn't copy this. Okay, I don't think there's much to be gained from copying this. But here's the thing. So we did the multiplication. We got 125,993. If we convert 439, the first number, into 10 raised to a power, then that power would be this right here. I'm not going to explain where that comes from yet, but you'll know by the end of the lesson. And if I convert the 287 into 10 raised to some power, that would be it. Okay, so when I'm multiplying 439 times 287, it's really like multiplying 10 to this power, which is that, times 10 to this power, which is that. Now remember the properties of exponents. X to the n times x to the m. What do you do with the exponents? You add them up, right? So in this case, because we have the same base, 10, then we're going to add these two numbers, right? And we get 10 to the 5.00347, which is something you can put in the calculator and find the value is 125,993. Okay, so by converting this thing from this number into 10 raised to some power, we change the operation of multiplication into addition. And addition, as we just said on the previous slide, that's easier. Okay, now that was important back in early 1600s or so, when they were first starting to understand something about the way the Earth orbits the sun and the shapes of the orbits and all that stuff. You know, think of the distances they had to deal with. The distance from the Earth to the sun is like 10 to the 12th meters, right? That's a lot. That is a huge number. If you're trying to do calculations with that in an era where you don't even not have computers or calculators, you didn't even have electricity, right? So it was very tough. It didn't mean they never did it, but you'd probably have like a bunch of monks sitting around a table, you know, for years trying to come up with one calculation. Then logarithms were created, okay? Logarithms changed the operation of multiplication into addition, and it made a lot of what followed in the 1600s possible. Like, for example, it was in early 1600s is when Galileo said, I agree that the Earth goes around the sun and not the other way around, right? He was just saying what Copernicus had said about 50 years before that. But it was only in the next 100 years that we figured out, you know what? The shape of our orbit, it's not really a circle either. It's actually an ellipse. And if you looked at that ellipse, it would look pretty circular. It's not like it's obviously like an egg or something like that. But it's a little bit more, it's Kepler. It's a little bit more in one direction than the other. We would not know that if we weren't able to do the calculations that logarithms made possible.